The question for this section is, now that we know how to evaluate partial derivatives and double integrals, what types of real-world questions can we answer with these? So what applications do these have to the business world? So the first thing we can talk about is partial derivatives as rates of change. So derivatives tell us about the rate of change for some given function. Once we start talking about partial derivatives, then they're telling us about the effect on a function from increasing a single variable. So for some given function, f of xy, if we calculate f sub x, so the derivative of that function with respect to x, what that information is going to tell us is what happens to our function f if we increase x by 1. So if our x value increases by 1, how will our function value change? Or it's at least giving us an approximate for that change in our function value. If we look at f sub y of xy, meaning we're looking at the first partial derivative with respect to y, that's telling us what happens to our function if we increase our y coordinate by 1, or our y value by 1. So in our first example, we want to look at applying this concept of rate of change, specifically for just increasing one of two independent variables. We have a firm that produces two types of calculators each week. They produce X number of type A calculators and Y number of type B calculators. And then we're given a weekly revenue and cost function. So given our revenue and cost function, which actually let me make a correction to a typo here, that minus 30,000 shouldn't be on that revenue function, so we'll scratch that. We want to find the derivative of the profit function with respect to x, the derivative of the profit function with respect to y, evaluate them at these specific xy coordinates, and then interpret those results. So in part A, the first thing to do is find the profit function. So we could do this by hand, or we can take care of this with Wolfram Alpha. So we type in the revenue function, and then we want to make sure we subtract that cost function in parentheses so that that negative will get distributed through. So we're taking revenue minus cost to give us our profit function, which we get here. So we get this negative 0.08x squared plus et cetera, et cetera. So that's our profit function. The next thing that we want to do in part B is find p sub x, so the derivative of that function with respect to x, evaluated at x equals 1200, y equals 1900, and interpret the result. So we can click on this result to avoid having to retype that. So we've got our profit function. So we could get the derivative of this function, and what we'll do is actually take care of some of parts B and C at the same time. We're going to find the derivative of this function with respect to x and y simultaneously. So we're going to get the profit function differentiated with respect to x and differentiated with respect to y. And the way this is going to be output is as two separate results contained in a set of brackets. So we have this first result, which is our derivative with respect to x, and a second result, which is our derivative with respect to y. So we get p sub x to be 111 minus 0.16x plus 0.09y and we get p sub y, the derivative with respect to y, to be 0.09y minus 0.18. Oh, sorry, that should be 0.09x minus 0.18y plus 185. So we have our two partial derivatives. Now we want to look at evaluating each of these at these coordinates. So we could evaluate that first partial derivative. For x equals 1200 and y equals 1900. And we get, in this case, a result of 90. So what this means in context is that when we're selling 1200 units of type A, so that's our x coordinate, 1900 units of type B, so this is the specific production level that we're at right now for the two items, then our profit will increase approximately $90 per unit increase in production of type A. So what we're saying is if we increase this production level to 1201, we would see our profits go up by $90. Or the other way to say that would be is that if we increase our production of type A calculators, then we would see an increase in profit. In part C, we want to look at the same thing, that same production level, but in this case we want to evaluate the partial derivative with respect to y. In this case, we get a result of negative 49. And again, we want to provide an interpretation. So the 1200 and 1900 are our current production levels. So when we're producing 1200 type A calculators and 1900 type B calculators, if we increase production of the type B calculators by 1 unit, then our profit's going to change by negative $49. Or another way to say that is it would decrease by $49. So in this case, if we increase production of type B calculators, we would actually see a decrease in profit, which would also mean we could flip that around. If we decreased the production of these type B calculators, then we would increase our profits. So when we calculate these partial derivatives, we can look at what's the best move for a company to make. Should they increase the production of one product or the other, and which is going to generate the better change in profit? So even though we're not specifically asked that in this question, in this case the better decision would be for the company to increase the production of their type A calculators, because that's going to yield the better increase in profit.